Hey everybody, I hope you're all having a great day so far. My morning's been pretty good. I think, yeah, I just want to get right into the programming, I think. So, oh right, I was able to fix the problem before where we had black lines where the alpha was supposed to blend. Well, you can't really tell now because... yeah, because they're the same color. But before, like right here, we had a little black line because of the way Inkscape exports images. Let me open it. So right here, where they're supposed to just blend into transparency, the color behind these alpha pixels is, unfortunately, Inkscape just puts it as black instead of having like what they call a bleed margin around here. So when our shader tries to blend the colors at this edge right here, it's actually blends it to black before the alpha, or before the pixel goes all the way transparent. So that's why we had that ugly little line there. But I was able to fix it by opening up the image in GIMP, which is just an alternative to Photoshop, basically. And I just opened up the channels and deselected the alpha channel. And then you could do color picker on this color, and then you just would go ahead and paint well, something like this. So it doesn't actually look like you're doing anything, but you're actually like painting over the black. And if I think I can change it so that I can remove the alpha channel. Okay, well it just sets it to white, but I'm actually painting the area behind here the same color. Kind of hard to explain, but that way, that when our game actually blends the texture, it doesn't blend it to black, it actually blends it to our foreground color while the alpha is fading out, so we don't get any ugly artifacts. So yeah, unfortunately I can't set that to happen in Inkscape, so every time I make a change here I'll have to go into GIMP and do that. Luckily it's not too difficult to do in GIMP. Let me see. Oh right, so today, another thing about the terrain that I don't really like, well, of course disregard the textures right now, they're all temporary, but like right here, it's just a very abrupt change in the lighting. And I've always said I want to do this where I'll have smoother normals, and I think that might be, well, you can't really tell. Let's go ahead to make it more evident what I'm talking about. Let's just make some temporary art files for the other tile types. Okay, so I'll just duplicate these. Turn snapping on, will it make it easy? Okay, there we go. Okay, so this is stone. Yeah, stone, so I need to make it a darker gray. Or not. I need to desaturate it, that's the issue. Okay, well the color doesn't really matter that much, but... and I guess... Okay, we'll keep this little swirl, just... It doesn't really make much sense for stone, but... Alright, and then I need to change the gradient color. Right, which is unfortunately not super easy. I think I'm gonna have to... Let's just take this color so I won't have to figure out a different one, which I think is maybe too contrasting. Well, it doesn't really matter right now because I'm just going to be temporary art. Okay, why is it still... Oh, I see. So this one... Okay, this is the same issue we had before. It's the same color, except the alpha is set to 0. So it's fading to the brown. So I need to do that and then set alpha to 0. I guess I'll just copy that so I don't have to mess with the dialogue each time. Okay, and then the margin. Oops, that's the wrong one. Okay, and then all these can just be flat gray. Okay, no, that's good. Okay, so now, oops, what did I just do? Now I'll make another copy for the grass. something like that. It's fine. Okay, I think that's too yellow. Okay, this one contrasts too much, I think. Okay, so now I gotta go and fix up the gradients like I did before. I wonder if there's an easier way to do these hexagon gradients because they're unfortunately kind of a pain. Alright, so there we go, that's good enough. Now I need to hide the grid. Okay, and so now when I export, we can see the black lines in action. So now I need to reload the file here. Okay, there's no way to reload it. A currently open file, so I'll just open it again. First, I'll select this and then, okay, I gotta turn off the alpha channel so we're only drawing in the color channels. And then I just got to paint over the margin right here for those two. The other ones don't matter because it's not, the UVs don't actually reach the edge. It's just right here where the game is going to blend with the alpha channel. See, I actually do have the color selected because when I go over an area without, where the alpha is not set to 0, I can draw, but when I get to an area where the alpha is 0, it disappears again. But I actually am still drawing. You just can't see it. Okay, so now if I export this, yeah. And again, I think, oh, another thing I had trouble with is that I realized before I was downscaling this to 2048 instead of 4096. And I can't really do that because that shrinks the margin as well, and the game logic thinks that the pixel, like the margin in each of these UV tiles, is 4 pixels long. But when I shrink it, it makes it go down to 2 pixels, so it actually would kind of well, it messes up some of the logic. I don't know if it's actually that visible, just because we don't have very intricate designs right now. But I actually think that the 2048 looked fine resolution-wise, so when I make the final image, I might scale everything down. But anyway, still, even with this huge texture, the asset bundle is able to compress the image down to just about 1 megabyte, so it's not really that big of a deal. Yeah, it's going to take it a little bit to build the asset bundles. I wish that the Unity would pop up a dialog. It only does it for this short time. Okay, so I'm going to open up the streaming assets folder, which is where our mod files are stored. And I need to drag that newly generated asset bundle into the test content mod folder. That way the game will load the assets in that bundle for our mod. And we should see just right out of the gate actually colored terrain instead of the black. Okay, and yeah, doesn't look super good, and there's some weird stuff. What's going on right here? Actually, okay, I think in the mod file, I didn't set up the claims correctly. Oh no, I did. So it's first and second. Okay. So let's look and see, make sure that everything is working as intended. Okay, I think I see what's going on now. So obviously these lines and the final art will need to match up. And really the only thing I have to do to make sure that happens is just make sure that this line is exactly in the center and that this is exactly in the center of the triangle. I don't think this one is not centered, I don't think. So that's why we get this weird little cusp. And then obviously, probably we'd want there to be a curve right here so these tiles can kind of blend together, but it doesn't work perfectly right now. What's happening? Oh, where was I just looking? Right here. So if I turn back on shaded wireframe so we can see the triangle. Oh, okay. I can't zoom in anymore. So I guess these two tiles have priority over the grass tile. I think because dirt just has a higher priority right now. So these two textures are drawn first, and then or drawn on top of the other textures, and the grass, which is the base tile, actually reaches in right here, and that doesn't actually look too good, so I'll need to keep that in mind. But I think everything works correctly. It just doesn't look that good right now. We need to have some final art. And the same issue right here. Yeah, I think in order to make this look really good, I'll need to somehow create a certain tile that only draws if the first and second are the same tile type or something. Because yeah, this is kind of weird. But maybe I could make it look okay. I don't know, we'll have to play around with that. But anyway, okay, so now we can definitely see the tiles. And even disregarding the wonky textures for a moment, it all just kind of looks flat because the lighting doesn't really affect it much. And that's mostly the angle of the light. So if okay, the Z doesn't do anything. I think it's, if I just slightly play around with the X, it starts to get shadowed. And that looks better, except it's like there's a very hard line. Okay, and we keep getting this weirdness with the shadows on the terrain. I think that might be another problem having to do with the normals being so sharp. So basically the normals point straight up on this face and then straight outwards here, and there's no blending. So I need to try to fix that. And it's been like a long running issue that I've had with the terrain. Unfortunately, it's kind of complicated to fix, but I think I might know a way to do it now. Let me see. So I have, what's it called? Tangent space visualizer. Okay, so this actually shows the normals for every point. And yeah, so here you can see these normals don't match, and ideally they'd all be this, like there'd only be one line here because the normals, well, there's 3 points here, even though they have the same position, but they have different normals. So ideally, whenever points share a position, they'd also share normals. And I'm going to try to get that working. Another thing I need to do, well, we'll just leave it how it is for now, but when I have it share normals, this top part is going to look very rounded because the game will interpolate the straight up normal to the average normal here over the entire triangle. And that's not probably what we want to happen because this should mostly be flat. So I think I need to add another like ring of edges here and also right here, and that will be the area where the normals will kind of blend together, so we'll get softer lighting. Well, the rest of the faces will be flat. So that's kind of my goal for right now. So let's get a little planning. Yeah, so okay. In order to do that, there's also something I've been thinking about where okay, how should I put this? In our terrain generator. Yeah, so okay, well, this is a good example. The blend values depend solely on data that's independent of like the position of a section. It only depends on the type of section and, well, the interpolation data is the same. It only depends on the type of section, so we don't really need to generate it for every single one. We could just generate it at the beginning of the game and then just reuse it. Another thing that would be useful is I could have like an entry for every point that would tell me if it's on the edge of a section, and then if it is, what section would hold the same, or the point at the same position, which I guess I'll call a twin point. That way we could use that to smooth the normals between them. And so I think I'll also tackle that at the same time. That would be a good optimization. What should I do? I guess consolidate data that only depends on section type. So okay, we have yeah, the interpolation values, blend values, and triangles off the top of my head. I think the collision triangles also don't depend. They only depend on the section type except for the owner block. Let me see. Yeah, so the point arrange data, that only depends on the section type. Okay, so then the board indexes is just saying what the owner is of the triangle. So maybe I should break this up so that we figure out triangle owners on per section, and then the actual collision triangles will be per section type. Okay, so I guess to make this more clear, we'll have the visual triangles and then the collider triangles, and then a note here. Triangle owners Okay, how should I put this? Break off triangle owners to a new system that runs per section. Okay, so we'll do this first. Okay, I also need to add twin point data. And one other thing also is I need to add like a neighbor map to each section that would tell it the index of its neighbor sections on every side, because this twin point data will basically just say, okay, the section to the southwest point 1 is our twin. But so in order to find that specific section, we would have to know all of our neighbors, and so that's what the neighbor map will be. So yeah, section neighbor map. Okay, so let's just take it one step at a time. I think, okay, the game is probably not going to be runnable for a little bit while I refactor some code, but I don't think there's anything I need to test right this moment, so it should be okay. Okay, so we're gonna have some code that is not, yeah, it's outside the section and the chunk, so let me see. I guess it should go above this terrain generation state. I guess I'll call it an archetype. Okay, maybe template is better. Alright, so I don't really need to store the type in it. And this is like trying to identify this section, so I don't need that. Okay, so this actually will move to the section template. Okay, so the bounds. So the bounds start. Oh well, no, these could change actually. For example, rectangle margins have different heights here, so the bound axis is definitely our per section thing and not per template. This, yeah, the interpolation data is definitely per template. Positions, normals. Are UVs? No, they're per section because we randomly pick some UVs, so that will stay. Blends is per template. Okay, we don't have that anymore, so oops. Get rid of some old code. Okay, and then both of these can be per template. Okay, so I'll just have a list of section templates, and the index of the section template will be just the index in this enumeration. Okay, whenever I do this, it's not really a really elegant way, but I'll just put a count value at the end of the section type that tells us the number of entries in this enumeration. Okay, so now the terrain mesh. So I guess I'll need to have a couple Okay, I'll need to have two lists of systems. The first will be okay. Like the template builder, and then another one would be the terrain builder or the mesh builder. I guess I should figure out what states I need to have in the template builder. Okay, so a couple things. Okay, the arranged data is not here anymore. Okay, and this should change to collider owners. I guess there's really no reason to refactor that because all the logic is going to have to change there. Okay, well, I'll still use the same type of system I'm using here for dependencies, although I don't really know if it's needed for the templates because we kind of just run one at a time, and it doesn't really need to be multi-threaded as much because we're not going to be working on multiple hundreds of sections at a time. But I don't know, why not? So we have state arrange, state lerp, state blends. I guess it's all plural, so I'll try to keep the pattern. Okay, I didn't spell visual at all right there. Okay, so this systems, I guess I'll rename this to mesh builders. A couple of these I can get rid of. Okay, well, this I'll just delete that because we're gonna have to come back to the owners in a bit. Okay, so let's see. If state dot templates count is 0, then we'll need to regenerate templates. So okay, so actually, how should I do this? So we'll need S templates and S meshes. Okay, so maybe I can just put this all in one. Okay. Yeah, this should be okay. It's a little strange, but it's just because the way this is built, coded. I think I'll just store everything in one array and then we'll update it all. I don't know. Doesn't really. Okay, let's see. If S meshes is waiting, this will be fine because whenever meshes is waiting, then also the templates are waiting. So oh, this should go outside the for loop. Not that it really makes any difference, but okay. So I won't actually need this function. It's just if the templates, if we need templates, I can just call state as templates, set it to waiting. actually do this a different way. Okay, so if it's idle, that means it's never run before. So really, let me... Okay, I see what's going on here. Here it's checking to see if everything is done. If everything is not done, then it updates everything. Okay, let's do it this way. If state dot s templates is waiting. Kind of do something similar here, except we'll loop through every template. Okay. I just need to make sure. Well, we don't really care about the arrange. That just is a. Oh, actually, we do. So I just need to make sure that all these are complete. Okay, so if it's all complete. Also, oh, I did this backwards. Okay, so yeah, these all should be not equal. Then I need to change all those ands to ors. Okay, there's something similar here that I changed. I also need to check to make sure that the collider or oh, it's going based on chunk. Okay. The one thing is that the collider. Oh, where is it? The chunk. Yeah. So you have the collider mesh, but it doesn't actually care about. Oh well, I guess the collider mesh builder also just builds the triangle owners. So yeah, that's fine. Technically they probably should be in a separate system, but let's leave it how it is for now. Okay, so if all that's done, then we set the S templates to complete, and so that might trigger some other systems to run. Alright, so I guess let's update some stuff in here. So the blend generation system. So it needs to wait. Okay, so it needs the point blurb data. But it actually doesn't need to loop through the chunks anymore. It should loop through templates. Okay, I guess I should rename this to T, so it still makes sense. I think I can get rid of this block. What else? Actually... Okay, well this is still fine because if meshes are waiting, then that implies that templates is waiting as well. But, okay, so if state.s templates equals waiting... Okay, that way we don't have to do this loop every time. Okay, so this means if the interpolations are done and blends are waiting, then we actually want to run. I guess I should pass a template. Okay, so the template type... Okay, I guess this does matter then. Obviously it matters, but I didn't think I'd have to store it in the actual object, but... Okay, so this is gonna just take some changing variable names, but most of everything should be the same besides that. Well, the logic is definitely the same. Okay, and then the board index, it doesn't actually change that much. Oh, it doesn't change at all, I don't think. Okay, and the bounds is the same. Okay, I don't think I actually use this class anymore, but I'll leave it. Okay, so the collider mesh, I don't need to fix anything here. Oh, I guess I do actually. Okay, because I have to get the collider triangle points from the corresponding template. State templates. Okay, so that's an easy way to get the template. Section to chunk. Oh, okay, so this is transforming the section point to the chunk point. Okay, so I'm not going to change any of this logic. I don't think I need to. Where does it... Oh yeah, so the owner builder's right there. Okay, so this is going to be quite a bit different. Oh, well, obviously, because this is the code or the class I need to break up between the collider triangles and the collider owners. Okay, also, the collider mesh, I need to make it wait on... Okay, it's already like that. So first off, I'm going to copy this and paste it into here. Oops. Okay, so I'll come back to this. So this won't build that anymore. And I think I'll copy this code from the blends because it's basically the same. Okay, what does this rely on? It just needs the arranged data. Alright, so again, I just got to do a bunch of copy and pasting to refactor this code. But none of the logic will change, thankfully. Oh, except this code is the code that's figuring out the triangle owner. Okay, so I gotta break out this part. Alright, there we go. Okay, so now the collider owner is going to be kind of the inverse of what I just did. So this needs to wait on board index. That's it, I guess. Oh yeah, because if we even get to this point and there's any chunks, then we know that the templates are complete because the section builder. Oh, actually, no, it doesn't. I was gonna say this section builder should wait for the templates to be complete, but it doesn't. I don't think it needs them. So, okay, so maybe I should go back. So we got if state.s templates is complete. And I'll add that to, well, the board index. It doesn't need any templates. Anything that actually needs the templates. Okay, so the same thing will happen here. Okay, and yeah, we don't do the triangle points anymore. Just the owners. So really all I have to do is just add a triangle. Okay, I could simplify this by just adding it directly to the list, but in order to make me not have to refactor quite so much. Okay, I actually don't need any of this code. Yeah, so it's pretty simple. Let's make this a little easier. So section, template, or not easier, but more future proof, I guess. State, templates, section type. So we know that the hex face, all the owners will be the same. So, okay, so collider, triangles. And I think as it, oh, well, it'll be slightly different for this actually. The first two triangles will be here, and then the second two will be this one. Fortunately, I'm not sure if there's a way that I can future-proof this. So if we ever change the number of triangles in a collider, I'd have to come back, but I'm not sure if that would ever happen. Well, it might. If I add like a terraced or different shapes of margins. Same with this. Well, there's two for each, so I could make this into a for loop actually, but it makes it really clear what's going on, so I'm happy with it really. Okay, so that was pretty simple. While I'm thinking about it, I'll go ahead and add this new system to the systems list. Collider owners. Alright, so now the layout. This makes the interpolation. No, it makes. Oh, yeah, it makes the interpolation data. Okay. And so that is part of the templates. So what I need to do here again is I'll copy this code from the blend template. And the layout generation. Okay, it depends on this arrangement, which is right there. So again, I've got to do some copying and pasting, but nothing really exciting. I could pretty much just do a search and replace to change all references to section to the template, but I don't know, I'd rather catch any big errors if they exist. Okay. So the normal, okay, this is the big thing that's going to change. And it does depend on the templates. So if state.s templates is complete. Okay, can I find the period key? But yeah, in this section, it really only depends on the positions. Okay, so here, calculate end section. So I need to, yeah, this is the first thing that actually uses the template and the section quite a bit. Okay, it's the number of triangles. Oh, right, I see what's going on here. Oh, right, because the triangle is actually... Okay, it's because we encode one triangle as 3 points in this array, so that's why I have to divide by 3. And what this is doing is just averaging... the cross products of a triangle. So we add it all here, and then at the end we normalize it, and so that kind of gives you a average normal for this point. Okay, so we'll come back and fix this up when I've finished everything. Or everything having to do with these templates anyway. Okay, so this arrange is actually another template system. Okay, and it doesn't depend on anything. So if sarrange is waiting, then it can run. Okay, and this just gives like some general information about the point arrangement in this type of section. Kind of just to save me from having to copy a bunch of logic between all these different classes. Okay, there, that one's done. Okay, so the position. Okay, it definitely does depend on templates, so let's add a check here. Oh wait, no, that was right. I don't know why I thought I needed to retype that. I just need to get the template associated with this section type, and that will tell me the number of points. Okay, well that works, but I could just do num points as well. And yeah, the interpolation data is also part of the template. But yeah, and the blend data. All right. Okay, so the section generation system, we're gonna have to come back to this, but it actually does not need the templates at all. So this works fine as is. Later, this is going to be the class I'll be responsible for creating the neighbor graph as well, but I'll wait to do that. That doesn't actually have anything to do with what we're working on. Okay, so the triangle is the last thing that is a template only class. We'll go ahead and copy this code again. And okay, what does the triangle depend on? Just the arranged data. Oops, too many dots. Okay, come on. Fingers. So again, is this going to be some refactoring here? Not very exciting. I have to say though that this train generation system itself has really come together. It's I feel a lot better about it than when everything was just in two classes. Basically, we had the visual mesh generator and a collision mesh generator. And so we had one class that basically had all this logic in it. I think breaking it up into sections and then trying to treat it more as an entity component system architecture really made this easier for me to understand. So I guess that's just a lesson. If you have a big programming problem and it's too hard to figure out, or you're having trouble figuring out what to do, try to break it up into smaller pieces. Okay, so the UV generation. Okay, so it needs the point interpolation, so we do need the templates to be complete to run this. Okay, so we only need the template for this number of points, so I won't like get a handle on it. Okay, then down here though we do actually need the range data and the interpolation data, which is part of the section or part of the template. Wait. State templates action type. Okay. Okay, the visible mesh. It's our last thing to update, and I think it does need the templates as well because it needs the triangles. So if the template is complete. Okay, yeah, this can go away. Okay, so we can get rid of this because the blends are not as part of the template, so they'll be ready by default. We gotta get the... I feel like typing in this out again, so I'll just copy and paste that. Okay, so one other thing I need to do is add and like, I guess a template. I guess I'll just call it template generation system. But all it's really going to do is just create the new template objects corresponding to each type. Kind of like the section generation does. In fact, I think I'll start with it as a base. Oops. Oh, no, it doesn't need to be public. So class template in system. Okay, and everything needs to be indented. I don't actually know if I need the game data or anything, but actually I know I don't, so I'll leave them in the constructor. Commented out the wrong line. Okay, so basically if state.s templates is waiting and state dot templates count is less than okay, section type count, then we need to generate them. Okay, and I'll just assume this will just finish in one frame because it's not really that intensive. Okay, so I guess I don't really need any of this. I'll keep... actually I don't need this either, because that's basically all this function's gonna be. Okay, no. I don't set anything because when I create them and then the other systems will need to run afterwards. Okay. State, templates, safe set. And this just creates a new entry in the list at a specific index. And it expands the list if the index is greater than the actual size of the list. Okay, we can just create a new one. And I just need to set the state values here, and the type, I guess. I just need to set all these states to waiting. And everything else is taken care of by the other systems. Okay, and also, let's see, switch. For certain section types, I don't actually want to create any class or any template for because they are not supported right now. So if it is unknown, I guess if count gets in here, I don't know how it would. Okay. And right now I don't support the edge rect margin. I should probably just delete that in general, but okay, so for any other thing, we'll create one for it. Okay, so now I just need to add this class to the terrain system list. What was it called? Template gen system. Okay. Add it backwards. Okay, so hopefully now when I press play, it will look exactly the same as before. Okay, now we got an error. Argument out of range. Oh yeah, it's not going to bring me there. Okay, so UV generation system at 50. saying the section type. Oh, right, because... Okay. Let's just... Yeah, I have this edge rect margin, which I don't even support yet. Just... Am I going to have any errors with that showing up? I do need to do the edge of the world at some point, but I don't know what that will look like. Okay, and then here it has a battle, but that's not ever assigned. Well, that makes sense because template should not need the current state of the game. Forgot to comment or stop the game. Index out of range, get item at UV 50 again. It waits until the templates are complete. Okay, let's actually look in this debug thing and make sure that the template data is making sense. Oh no, okay, templates is set to 0. So how is this running already? Okay, so it waits until the templates are complete. I did a safe set here. Oh, did I do this wrong? Let's see if there's nothing. Oh, well, no, that's okay. Oh, I think I know what's going on here. So here, yeah, back. So it says if the template is waiting, but then this goes when before the state templates has even been set. So we know if this is 0, then it's not complete. So I can just say state templates count is greater than 0. So if it is 0, then we know it's not complete. So that takes care of that. I think what was happening is it was saying the templates were complete before any had actually been created. Okay, so still getting an issue. At line 87. Oh, okay. Where is it? Template? Here. Okay, so right here I actually do need to do this, but I need to set the initial state to idle. Okay, so let's change the way subsystem ready state. Okay, so if it's unknown or count and its state is set to idle, which means it will never run. Otherwise, we'll set it to waiting. And then I guess I will make a little dummy object for these dummy section types. Doesn't really matter that much. Okay, so it didn't actually generate anything. Okay, so it says that visual mesh, yeah, they're both waiting. Okay, so this is it, chunks. So, for some reason these are waiting. Positions is waiting on something. It's the templates. Oh, the template is idle there. Oh, okay. Yeah, it's because everything that needs a template is waiting because this code makes sure that everything is complete. So I guess I should... Okay, so if this equals waiting. So if it's idle, that just means that we don't even care. It's not going to run. Like it's not needed. Okay, there we go. And yeah, it looks exactly the same as before. So that's what I wanted to see. But we did dramatically decrease the amount of data we have to store per section. Now we just store only the information that actually changes. I guess I should check to make sure that the collision still works. Let me... Where's the class that does that? Mouse pick. Yeah, so this log will tell me whenever the mouse pick changes. Okay, so yeah, we're gonna get spammed a bit, but that's okay. So now I'm over block 1. That's not right. This should always be block 1. Okay, let's go. Okay, I need to be able to see both at the same time. And I have to see the log. So this triangle is 0. This... Okay, there... Okay, so... Okay, I should change this to just be shaded so we don't get confused. So the light green lines are the vertexes. Or the mesh for the collider. Okay, so it changed... Okay, it's still 1. Yeah, this whole thing should be 1. But for some reason it changes to 0. What about here? This should be 0, and then as I move here, it should change to 1, but it doesn't. Did I somehow get the types mixed up, maybe? What about the triangles? So it should change between... Okay, 8. Oh no, that should be 1 right there. And then... Okay, it's hard. It's like looking in a mirror. I'm trying to move the mouse while looking at the editor. Okay, that is wrong. Okay, so these triangles are just all messed up. Let me think. Oh, I know why. Okay, I messed this up because I add 1 triangle for every tri-point here. Okay. But that's actually, so there's, I'm adding this index 12 times because there's a triangle point, or there's 12 triangle points for 4 triangles. Okay, so I guess I'll unfuture-proof it because this code is not future-proof anyway, so. Okay, let's try that again. Hopefully that was the problem. So it's kind of just offsetting. I'm surprised it didn't complain that I had like a different number of owners than the number of triangles, but I guess the triangle or the triangle owners aren't actually part of the mesh, so okay, this time I'm gonna try and make them the same, so it's gonna be a little easier to. Oops. Okay, so as I move it against these triangles, it should just stay 1 the whole time. And it does. And then here, this should be triangle 1. That should be triangle 1. 0. 0. And then this is all 0 except when I select the egg dino, obviously. Then this is 0. It goes to 8. 8. 8. And then this should be 1. 1. 0. 0. Okay, so it looks like it's all fixed now. Okay, thankfully that was just the problem. Oops. Okay, so yeah. That wasn't too bad. Finished all of this. Oh, except the twin point data. Okay. Do we want to do that first or the neighbor map? Well, they're kind of independent, so it doesn't really matter. I guess let's think, how am I going to store that? Looks like the song has been on forever. Okay, so for the neighbors, I need to know which neighbor. Oh, also, okay, some points can have triplets too, or even more. Because, like, the hexagon, corner of a hexagon has a twin point. Oh, let's bring up the map. I can explain this better. Okay, so again, if I add that tangent space, change this back to shaded wireframe. So right here we can see that there's, trying to get a good view. Okay, come on thing. Okay. Well, there should be, okay, this one you can see a little better. There's 4 normals. And so that means that there's 4 points that share the same position, so they're actually, was it quadruplets? Yeah, quadruplets. We have the point on the hex face, and then the point for each rectangle margin, and then the point for the triangle margin. So what I need to do, okay, that means that every point, kind of, I think a maximum of 4 neighbors, but well, maybe we shouldn't even depend on that. Okay, so right here, this has 4. I don't know if we'd ever get more than 4, but just in case. Then of course this one has no twins. There's only 1 point there. Okay, but I want to be able to look up the number of twins by the point index, so it needs to be like a 2D array or an array of lists. Okay, so let's see. It'd be like, I guess I'll make a system serializable public class point twin. Well, I can't do section type. Okay, the thing is, like, how would I need to number the neighbors. Okay, I guess I'll need to just make a new enumeration, I think. Like, enum point twin neighbor type. So I guess we'd either have a rectangle margin, try margin, and a hexagon. Let me see here. So right now how I kind of index neighbors is I just go by the side. So like this is side 0, so that's neighbor 0. And I do the same thing for triangles, like this is at corner 0. And then I guess for a rectangle, the neighbors would just be at the near point. We could go kind of like that. Maybe the best way to do it, since it's different, whatever section type it is, that I just index them based on oh, okay, I just realized okay, so the template obviously can't change based on what's around it. The only issue is these margin section types might be different because I know for a fact that the type for the edge of the world will be a different section type. So that means that the twin indexes might be different. So I guess I need to, these twins will need to be generated on a per, it's kind of like per pair of section type. Okay, so that's actually, okay, so how do I want to store that is the question. I could have like a table lookup, but it might be easier if I just did just a flat list and then I just looked through to find the list I actually need. That's not as efficient, but I don't think the list will ever get so big that it really matters that much. And if it does, then I can try to find something more efficient later on. Yeah, I think I'll go that simple way first. So we'll have... let me see. Point twin. I guess I'll just call it point twin data. Okay, so now, yeah, we can just use a section type for this. This would be the neighbor type. And then, okay, yeah, the side, or I guess the neighbor index. So I guess how I'll do it is neighbors will just be ordered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I could go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know. What would be easier? Probably doesn't make much difference. Okay, and then I'll need to have for each point and yeah, I guess for an array for number of points I need to have which points. Okay, what? Okay, so I could have just an array here. That'd be like, okay, point 0 and our here has the same as point whatever in this section type. Problem, well, I guess it's not that big of a deal. I was gonna say that's introducing a lot of data, but not sure if there's a better way to deal with it. I kind of like it so that I'd have an array that's just like, okay, this point 0 has index our twins here. But finding the twin vertices is just not easy. Okay, another way I could try to handle this is that I don't actually know the twins, but I know that I'm on the edge of my section and that neighbor's... Okay, well that would have... Okay. That would make me need to figure out information about my neighbors and that would be like code duplication, so I don't like that. What I was gonna say, sorry, I kind of doing stream of consciousness here, but I was thinking that if I just know my point and I don't actually know, like have all that neighbor data. Okay, hopefully the game will run. I don't know if okay, it does compilable. I think it'll be easier if I have the map up. So let's say I'm at this point. I'm trying to do the hexagon face. Oops. At this point here. So since I know I'm at this corner, then my neighbors would be rectangle sections and then a triangle section, and since I know that both of the neighbors here are flat, then my normal would be straight up, so that's no issue. Then here, I know that my neighbors would have to check both of these neighbors to see what their altitude is. And then I could kind of calculate the slope here, but that... See, I don't like that because for one, the code for normals, like, or this hexagon doesn't actually know the surfaces of these neighbors. So I'd have to recalculate that, and then also it assumes that these margins are all flat, and I might change that later. So then I'd have to continually update the normal generation every time I change the geometry of these margins, which I don't like the idea of. So I think really the way I have to do it is somehow like find the twin vertices, like I've been saying, are vertices that share my position, but it's just not an easy problem. It seems kind of funny that it's being so difficult, but... Okay, so how I'd really want it to work is that for this point I'd have like a list of all my twins, but like I said, the templates have to be constant for this type, and so they can't have different data depending on what the neighbors are. So maybe the way to do this is the templates have like point data for every possibility, and then the actual sections will have a list of neighboring points. And I'll just make some system that will translate between the two. That's probably the best way to do it. Okay, and maybe instead of doing a list, I could do like a list of int vector 2, so that would be my point number 0 has a twin at the neighbor point number 6, for example. That's probably better than having an index for every point. This will be so twins. Okay, and I guess I'll just say my point index and then neighbor point index. Okay, so in the template, yeah, we'll have every possible combination. Now I think about it. Does this actually, okay, let's take a rect margin for an example. Be nice if there was some way that I could, well, there is a way to do it, but it's kind of a lot of work, but some way I could draw the point index over each of these points to help visualize. But let's take this margin, for example. Since it's facing east, this hexagon is the parent. That means that this is like 0.0, for example, and that's 0.1. So this vertice has a twin right here. I think this is 0, 1, 2, 3. So my 0.3 has a twin at the neighbor 0.0. But then over here it's not the same because the parent hexagon is this one. So this is actually 0.01, 2, 3, 4, 5. Okay, so I guess the side does matter, which is kind of a shame because otherwise I could just... I wouldn't have to have this index. Okay, but I can have like a list here, and that would at least cut down on some duplication. Okay, so anyway, we'll need to generate this, and then the section itself. Okay, well first we'll need to have the actual chunk, our section index for all of our neighbors. I don't know how I want to store the neighbor graph, because it's kind of complicated just like this one. But okay, definitely I'll need a index, something like this, int. So for 0.0, we'll have a list of all twin indexes. Okay, never mind, that doesn't actually work. Because I have to store more than just an integer. Okay, it's like an int vector 3. Okay, so vector 3 int. So yeah, my point. Again, I kind of wanted a list or an array, so I guess okay. Is the index, and then the vector 2 ints have the section index and the chunk. Okay, that's another point. Also, I can have neighbors that are in a completely different chunk than me. So I guess it does need to be a vector 3 in it because it has to be the chunk index, then the section index, and then the point. Yeah, this is kind of a pain. Okay, so in order to generate this, I'll need to somehow... Yeah, I'll need to have the neighbor map. Would that be... Okay, no, it can't be per chunk. It has to, again, because sections can have neighbors and other chunks. I was kind of hoping that this class could just build the neighbor map or neighbor graph itself, but problem is I don't call these if they're in a neighboring chunk. Okay, so maybe I should call them if they're in a neighboring chunk, but just don't actually add a section. I just add a link in the neighbor graph. Okay. All right, so how do I want to store this? Basically, there'll be... I could store it per chunk. Although I kind of like it being global. But I want to do something like this where I can index by the chunk index and then by the sector index, and then it would give me a list of all neighbors. I don't have to search through it. No, let's chunk first, and then... Okay, so first... do something like that. Maybe this needs to be like a separate class. I don't know how you do an entity component based graph. Well, I guess you just have a list of points and then edges between them, but that's not super quick to index. Could do a dictionary. And then I have a vector2 int, which would be the chunk and the index, or the chunk and the section, and then that would, I could just have a list of all my neighbors. Okay, so public struct neighbor. Actually, can vector2 ints? Well, they've got to be able to be used as a key, because it's a default data type in Unity. So this will be edges. Chunk index and section index. Oh wait, no, that's, I don't need that because that's this information. Oh no, I do need it, okay. And then the side. that tells me that it's my side. Okay, and then from the section index, I can actually get what type it is. Let's just say, I'll just call this local index. Okay, so now the section generation system, can it generate that? Again, I don't... Okay, so hex face, I could just say, okay, I don't know the indexes when I call this, so it'd be better if when I create this hex face, I could like add myself to the graph and it would automatically index me into the different arrays. Okay, yeah, this isn't working out as I hoped it would. I thought I had a clear plan. Maybe I'm... Okay, I've got to be able to do this. Yeah, because I already walked through other ways I could calculate normals and it's just not going to work. And I definitely want to be able to do this because I don't like those. I don't like these hard edges. Doesn't match the rest of the game. Just gotta try this. Think of an algorithm. Well, if I could make a graph of neighbors, then I'd know how to do it. But it's just trying to set it all up because I don't know the section indexes until they've been generated. And I can't like pre-order the indexes of the sections because like, okay, let's take for example, well here, because I already know that I want to show a stone tile here if there's a stone underneath this dirt. And so in that case, I'd want to break this up into two sections. And that messes up the whole indexing. Like right now it's pretty regular. It's just a hexagon and every hexagon has the same number of triangles and rectangle margins. But when I start doing stuff like that, it will be different. And then like later on I'll have things like water and all kinds of stuff, so I can't have just a regular grid of sections that I can refer to. Okay, so maybe I should just generate every section and then I loop through it again. And then based on some kind of registry, I could build a neighbor graph. So maybe every section like plants itself, okay, my parent, or I'm connected to the block or the cell at 0, 0 or 0, 1. And then based on what side it is, we could say, okay, you're my neighbor to the east. I think that's how I'm gonna have to do it. Again, like later on when I have more complicated margins, it might be a little bit more difficult. Let's say I had to break this up into 3, then this margin doesn't actually have a parent hexagon. Although I guess I could just say, okay, since I'm in the middle, I go to the one to my north or whatever. So there's ways to fix it. Okay, so I think that's what I'm gonna have to do. So I want to have like an index here, and it'll be on a per cell basis. So I guess neighbor graph is actually something else. Oops. Kind of just creating data classes here because it helps me structure how I want to do the code. What should I call this? Like placement, registry, I don't know. Okay, and then entry. So I guess, okay, we'll have an integer. This will be the parent cell. And then the side, or let's call it the parent side. And that's enough to handle every type of section we have now. And so I guess I just have a list of these for every cell in the game. Entry, okay, so let's go with this first. Okay, and I'll need to have the section index here. So public int chunk. Okay, and so I don't know if I'll use this neighbor graph yet. I guess I'll comment it out just so it won't cause any problems. I think I do like this way of handling twins, but I'll need to like devolve this data into this some type or somehow. So I'll figure out how to do that later. Okay, so anyway, I need to add the placement registry to this. So when I create a hex face, I know my hex index. How is that actually? Okay, so I'm using this as cell, but because this hex index is supposed to imply the like it implies our altitude in it, whereas cell does not care about altitude. Okay, so I guess I'll rename to try and keep things consistent. Okay, so that's fine, but after this I need to add two things to the placement registry. Or no, just one for this. So placement cells, add new. Okay, I don't know my chunk index, do I? So I got to pass that. Oh, no, I do, chunk index. Okay. I don't know my section index necessarily. I guess I'll return that with add section. So we'll return state chunks, chunk sections, count -1. Okay, and then what is it? Parent cell is that. And then the parent side doesn't count for hexagon. Okay, did I add a new like add placement probably. Okay, that will clean this up a little bit. Okay. Yeah, I'm feeling pretty good about this, I think. Okay, and then we'll do the same thing for this one, except now we do care about the side. Oh, it's given to us. Okay. But not the cell index? Okay, so we do need to pass that. Oh, right, I just need to rename it. Okay, and now I need to register myself for the neighbor. Okay, I do have this neighbor position. And okay, so we'll add placement. Okay, so I need to figure out if the chunk, if it's the neighbor's in my chunk or not. Oh, right, and also, fortunately, I've got to go soon. Okay, but how would I figure out if it's in a different chunk? I have this information. And I guess I would just, so I have the chunk offset, and I would just see if the new cell index is greater than chunk offset plus the number of rows or columns or whatever. Let me see. Private int inside chunk start chunk. Oh, I don't really need to pass that actually. I would just pass the cell index. Okay, well this is pretty easy to chunk offset. I won't worry about it. Okay, actually I don't know that. I don't need that at all actually, so that makes things a little easier. Okay, so the cell index, I need to change that to a hex position. But I need to get the rows and columns, but actually I already have the hex position, so... Oh wait, I'm thinking about this wrong. I need to... Okay, yeah, because the I'm, or this section is in this chunk, and that's what this is. Okay. So yeah, this is still fine because this is identifying this specific... Oops, I'm doing the wrong thing, but... Yeah, it's identifying this specific section, so it's... I don't have to do anything else. I just need to do... I need to flip the sides, so we have 6 sides, so this should be side +3 modulo 6. And then the cell index, I just need to turn this to the cell index, which is neighbor position to board index. Okay, I do know the board, so I don't have to worry about that. Okay, and then similarly, a triangle has, oops, 3 neighbors. Okay, yeah, I need to rename this again. Okay, and this is a neighbor clockwise position, so... Okay, let's see. So the clockwise neighbor is... Okay, so for this triangle, this neighbor. So this is our side 0, but their side +4. Okay. Okay, and then the other one is just the counterclockwise neighbor, and it's my side +2. Alright, so now we register ourselves as under this specific place on the map. And so some other class can come and figure out the specific section's neighbors after all the sections have been generated. And then from there, it can figure out the twins using that data and the section template data here. And then once we know the twins, we can go into the normals and it will be able to find out which points have a twin, and then it can look at the triangles and the twin sections and add those to the average, and that way we'll get blended normals, finally. Okay. Well, I know what I need to do. So I need to decompose position into into section neighbors, and then decompose section neighbors into twin points, and then add twin points to normal calculation. And I also need to add neighbor data to the templates. Okay, so we still got quite a bit of work to do, but maybe... Okay, well, I did do this actually, but... Okay, I think I'll move, because it's kind of its own little thing. This should actually be something like that. Okay, actually, yeah, this is duplicated. All this just to smooth lighting, but I kind of knew this was coming up because one problem with breaking the map up into these sections is that they don't actually know much about their neighbors because they're supposed to be independent, and for the most part this has worked so far, but the normals actually do need to know about their neighbors. But luckily I don't think it's gonna be too difficult now that I actually know what to do. So we'll continue work on that tomorrow, but I'm gonna go grab something to eat. So yeah, I hope you all have a great afternoon, and I might be back later. I don't know, it's kind of a busy day. I do really want to work on that platformer on stream, so I'm gonna try my best, but we'll see. And but anyway, thanks everybody for coming by again. If you want to be notified when I go live, which will definitely be tomorrow around noon Eastern, where we'll finish up with these normals, feel free to follow me here on Twitch or on my Twitter. I also have a YouTube where I upload every stream if you'd like to catch up on any you might have missed, and a Discord channel where you can chat with me throughout the day. I'd love to talk to you. But I'll have links in chat if you're interested, or you can check out video description if you're on YouTube. And yeah, I think that's it for me for now. So again, have a great afternoon, and I hope to see you later. Bye-bye.